There is a giant planet in our cosmic backyard that humanity has essentially ghosted for 40 years. That planet is Uranus, and NASA is finally building a flagship mission to break the silence and penetrate Uranus as deep as possible. Our entire understanding of this giant comes from a single fleeting encounter. In January 1986, Voyager 2 flew past Uranus at over 60,000 km per hour and gathered a collection of distant pictures of a pale blue ball that looked deceptively boring on camera. That's it. Uranus rotates completely on its side, tilted at an impossible 98 degrees. It's literally rolling around the sun like a cosmic bowling ball, likely because a massive protoplanet smashed into it billions of years ago and permanently knocked it over. Its magnetic field completely ignores the standard instructions, sitting totally offset from the planet's center and wobbling erratically. Now add in atmospheric winds raging at 900 km per hour and temperatures dropping below -220 degrees Celsius. But the closer we look, the weirder it gets, which is exactly why NASA officially designated the Uranus orbiter and probe as its highest priority flagship planetary mission. This isn't another rapid drive-by. This $4 billion project involves a dedicated orbiter spending years mapping the system, paired with a heavy-duty atmospheric probe. This probe will dive headfirst straight into the freezing toxic clouds of Uranus, recording raw data on pressure, wind speeds, and chemical compositions until the extreme atmospheric pressure violently crashes it out of existence. No more knocking on the door, we're breaking and entering. The orbiter itself is basically a flying planetary science lab. It will carry high-resolution cameras to map Uranus and its moons, spectrometers to identify chemicals in the atmosphere and on icy surfaces, magnetometers to investigate the planet's bizarre magnetic field, and instruments capable of peering deep beneath the cloud tops. Together, these systems will allow scientists to study the planet's interior structure, weather systems, rings, radiation environment, and hidden ocean worlds from orbit for years rather than hours. And the targets around the planet get even better. Uranus has 27 known moons. Some are showing signs of violent recent geological activity. Scientists strongly suspect they might be hiding massive liquid water oceans beneath miles of thick ice. In space science, wherever you find liquid water, you find the ingredients for potential habitability. We aren't talking about alien marine life just yet, but finding active oceans this far from the sun could completely rewrite our understanding of how common life is across the galaxy. But getting there is a brutal logistical nightmare. Uranus is nearly 3 billion kilometers away from Earth, so to save fuel, the spacecraft will have to perform an aggressive gravitational slingshot around Jupiter, stealing a fraction of the gas giant's orbital momentum to launch itself into the outer solar system. Even with that massive speed boost, the journey will take roughly 13 years. But the payoff is unparalleled. Most of the exoplanets we are discovering around distant stars are ice giants, roughly the size of Uranus, not Earth. By finally understanding this mysterious blue anomaly, we unlock the structural blueprint of thousands of worlds across our galaxy.